Hello, welcome to this video. This is 8-6 and we are talking compound interest. We're going to be utilizing exponential functions and exponential models to help us calculate how much money we can possibly have in an account or the value of an account utilizing compound interest. Okay, so let's go ahead and let's talk about compound interest. Now, a bond is a type of investment that you can buy with cash for which you receive payment or interest. Now, when interest is paid to you at a specific time period as the bond matures, it is called simple interest. That's just paid out. Now, if that interest is invested back into an account, then you earn interest upon interest upon interest upon interest, and that is compounded, and that should resemble an exponential model to you. Now, for an example, when you have $1,000 and you buy a bond and it matures after 4 years, paying 5% annual interest, and that interest is paid out every single year to the investor, that is called simple interest. And here's an example of that. The value of the account is worth $1,000. Okay, and at the end of a year, you earn 5% of that. That's $50, and that's paid out to the investor. Now, the value of the account at the end of that 1 year is still $1,000. Okay, and we can go through this every single year. So for every single year, $50 paid out to the investor. Okay, and then the interest accrued at the end of those 4 years would be $200. Okay, so the function for the value of the account, V of t, this would be a constant function because V of t is just constantly $1,000, just always 1,000, regardless of what it is, okay? But now, okay, I can go ahead and I want to introduce compound interest. So what happens if that interest is reinvested into the account? So at year one, we go ahead and we have $1,000. At the end of it, we get $50, but then we invest that back into the account. Well, now the account, the value is $1,050, so I'm going to earn 5% of that, and then you'll notice that I earned $2.50 more. Okay, $2.50, big whoop. Well, what if this keeps compounding? It keeps accruing more and more and more. And you'll notice that at the end of year 3, we now earn $55.13. And at the end of year 4, $57.88. And this is very, very valuable if you have you're investing in like a CD or if you're investing in an account for your retirement, right? There's a couple of different types of accounts, like an IRA or an IRA Roth, where they kind of differ upon when you're taxed, but you invest until you retire, right? So imagine this accrues, your accounts keep getting bigger and bigger. It's like a snowball effect. So when you retire, your account has lots and lots of money in it. Okay, sorry, I was a little extra for a second. The money earned in the interest at the end of the 4 years, if we add up all of these values, now is actually bigger than the initial $200 from the simple interest example. If you add all these up, you get $215.51. So you'll notice, right, over those 4 years using compound interest, you get $15.51. Okay, so what would the function be that represents the value of the investment at the end of a year t? Well, it's actually an exponential growth function, and in the last lesson we talked about creating exponential models. So the value of the account, V of t, is going to be equal to the initial investment, which is $1,000, times 1 plus r, so 1.05, right? That's the growth rate is 5%. Raised to the power of t. So there is our exponential growth function, okay? And we could make that following the principles from the last lesson. So the objective today is to solve problems using compound interest, and what we're going to do is we're going to introduce a function which actually kind of mirrors what we did in the last lesson for a value of account. So here is the function v of t, and this is just a general function which can model accounts and investment. And that is V of t equals P, which is your principal, okay, times 1 plus R over N to the power of N T. And actually, now that I'm talking about it, I don't want to go ahead and highlight all of it. Again, P, this is your principal amount, your one-time deposit. Okay, there's P. R is your annual interest rate. So whatever the rate of the account is, right? The higher, the better. Okay, there's your R. N is the number of times the account is compounded. And we'll go ahead and talk about different types of compounding here in a second. Okay, and we divide that by R and then also multiply that times T, which is T is the amount of investment, the time that the account is accruing interest. Okay, so let's go back to the compounding. So say I want to compound once annually. This is one time a year, so then N would be equal to 1. Now, if I compound semi-annually, that's every 6 months, okay, then N is going to be 2. Okay, so notice I'm compounding 2 times more. So what I have to do is I have to divide that rate by 2 and then also raise that to my power. So it'd be to the power of 2t. Okay, well, what happens if we compound quarterly? Well, quarterly, right, think like a quarter, in quarters in schools, right? That's 4 times a year. So N is equal to 4. How about monthly? Well, how many months in a year? 12. Okay, and then how about daily? Well, there is 365 days in a year, not counting a leap year. Hey, it's actually a leap year, 2020, right? February 29th, if you were born then, whoop, whoop. Okay, not many people. I asked Mr. Schwarberg, I said, who are some famous actors or people that were born on that day? The top of the list was Ja Rule. Do you even know who Ja Rule is? Okay, let's go ahead and look at an example. A person invests $3,500 into an account that earns 3% interest compounded annually. Okay, so they want us to write a function that models the situation. I always tell my students, make sure you kind of identify the information that's given here. We're told that a person invests $3,500. That is the principal amount. What we're also told is that the interest rate is 3%, okay, and that this is compounded annually. So I know that my rate is equal to 3%, which written as a decimal is 0.03, okay, and we're compounded annually. So that means that, I was going to write it in yellow, that N, the number of times, is equal to 1. Okay, so let's go ahead and construct a function. V of t equals P, okay, that's 3,500, times 1 plus, okay, my rate, which is 0.03. Okay, notice I'm not dividing by N because N is just 1. So if I divide it, it's not going to do anything. Okay, to the power of t. So there is our function. Oh, actually, whoop, I lied. Make sure you simplify this. What's 1 plus 0.03? 1.03. So simplify that. Okay, part B. Determine the value of the account after 5 years and 3 months. So what they're doing to us here is they're saying, hey, T is equal to 5 years and 3 months. So if I want to go ahead and kind of write this out, this is 5 and 3/12. You agree? Right? So written as a decimal, that is 5.25. Okay, so that's T. So now what we want to do is we want to go ahead and evaluate what is V of 5.25. So we plug this in to our calculator, and here's what we get. Okay, we get $4,087.55. Okay, so that would be $4,087.55. Okay, so you want to go ahead and make sure you write a sentence. And boom, there you have it. So there is our sentence. That's the value of the account. Okay, part C, it says how much is earned in interest over the 5 years and the 3 months. Well, I know after 5 years and 3 months, the value of the account is $4,087.55. Well, how much did we start out with? Well, we started out with $3,500. So I can go ahead, I can do some math, and I know that we have approximately $587.55 accrued in interest. Okay, so we're going to go ahead and write a sentence. Okay, and there is our sentence. Math, magic. How did I write that so fast? Okay, so there you have it. All right, next example. We are told that a person invests $1,200. Okay, so there is our principal, right? It's an initial amount in an account that earns 2.5% annual interest, and then they tell us that it is compounded quarterly. So what they're telling you here, when they say it's compounded quarterly, is that n is equal to 4, right? So I'm compounding the interest 4 times. Okay, so what we want to go ahead and do is we want to write a function that models this. Okay, so v of t is equal to the principal, so that's 1,200 times 1 plus, okay, our rate, which in this case, your rate is 2.5%. So written as a decimal, that's 0.025. Okay, so I'm going to add that, 0.025. And what we also have to do, no, that was right, 0.25, is we have to divide it by 4, because I'm compounding quarterly. Okay, now since I'm compounding quarterly, the times I multiply is also going to be multiplied by 4. So I raise it to the power of 4t. So there is your function, and then simplified, we get v of t is equal to 1,200 times 1.00625 to the power of 4t. Okay, so there is the function. All right, part B says find the value of the investment 11 years and 7 months. Okay, so now I know that t is equal to 11 and 7/12. Okay, so I'm going to go ahead and I'm going to plug that into my calculator, or into my function. So v of 11 and 7/12. Okay, 1.00625 to the power of 4 times 11 and 7/12. Okay, so I'll go ahead and plug that into my calculator. Okay, and here's what we get. So our answer is $1,601.60. Now, maybe you're asking yourself, how do we deal with the 11 years and 7 months? Well, I can take 7, I can divide that by 12 to convert to a year. So here's the number that I got. Now, I utilized, you'll notice, 5 decimal places. I want to be as accurate as possible, so I only use, I don't round less than 3. Normally we go minimum to 3, but if I'm including that to get an answer, I tend to use 5 to be more approximate. Okay, so let's go ahead and write our answer. Okay, and there is our answer. So yeah, that's it. Just notice that this problem just differed. We weren't compounding annually, we were compounding quarterly. Now, if they also said monthly, then n would be 12. If they said daily, then it would be n would be 365. Okay. All right. I have a couple of practice problems for you. Please go ahead, pause the video, try this, and I'm going to show the answers. All right. Hopefully you have tried this. Here is the solutions. Okay, and then here is the next practice problem. Please pause the video again. Please try these. Okay, and here are the solutions. All right, that is going to do it for this video. I'm going to split in this video in half, really. Well, it's not really half. I just have a one example and maybe a practice problem or two for you when we talk about continuously compounding. Okay, so that one will be next. Catch you next time. Peace.